Welcome to week 5 of business analysis techniques. This is the spring 2014 quarter, and we're going to work on chapter 7 of the textbook. Chapter 7 is your reading material, and there's also chapter 7 PowerPoint attached. And to make sure we have time to go over all 3 problems, I'm going to get right into the homework assignment. Here's the worksheet we're going to work on. So we're going to use the solver tool that we installed in week 1. I had you install that to make sure you were able to, because we're going to start using it this week. And if you read through this problem, basically you're a manufacturing firm and you make 2 products, air conditioners and fans. And for each fan, you make a $25, each air conditioner, you make a $25 profit. For each fan, you make a $15 profit. So you're going to fill that information in here. This is how much profit you make per unit. So to get your maximum profit, to maximize your profit, you're going to put a formula into this cell that says to take the number of units of air conditioners and fans times the amount of profit you get on each one. That's going to be your profit. So solver is going to fill in how many units you need to produce to maximize your profit. And so you're going to take the number of units times the profit per unit and put that formula here. And you've also got 2 constraints that we're given. We're given information in the problem that says you've got wiring, and each product requires a certain amount of wiring. Air conditioning requires 3 hours of wiring. Fans require 2 hours of wiring. So you're filling this information in. This isn't on your spreadsheet right now. You're going to fill this in. And then you've got a drilling constraint. Each air conditioner requires 2 hours of drilling. Each fan requires 1 hour of drilling. So you're going to fill in this information. Now, what this problem tells us, if we read up here, is that in the next production period, we've only got 240 hours of wiring time available. So the total amount of wiring, however many air conditioners times 3 hours each of wiring, plus however many fans we're going to produce times 2 hours of wiring, total must be less than or equal to 240, because that's all the hours we've got. So you're going to write a formula in here that multiplies the amount of fans and air conditioners times the amount of wiring, and that total goes here. So that total has to be less than 240. And then you're going to put another formula here that takes the number of fans and air conditioners times the amount of drilling. The amount of drilling has to be less than 140, greater or equal to or less than 140. So you're filling in this information from the paragraph. You're filling in this information from the paragraph. You're going to fill in a formula here. You're going to write a formula that multiplies the number of these items produced times the profit. You're going to put a formula here that takes the number of these items times the amount of wiring required. You're going to put a formula here times taking these number of items times the amount of drilling required. So once you've got your formulas all here, you've got all this data in here, you're ready to go to solver. So you'll go to solver, to the data tab, solver. And what are we trying to do here? We're trying to maximize profit. So the set objective is the profit. That's the cell we want to click on and put into the set objective. What are we trying to do to profit? We're trying to maximize it. So we've got maximize clicked here. And how are we going to maximize profit? By changing certain cells. The cells we're going to change are the number of units. We're going to adjust the number of units to maximize profit based on the constraints that we have here. So we have some constraints. One of the constraints, just look at them. One of the constraints is that this total amount of wiring here has to be less than or equal to 240. Another constraint that we have is that the total amount of drilling has to be less than 140. So those are the 2 constraints. So we want to maximize profit by changing the number of units subject to these 2 constraints. You're going to click solve, and then solver will tell you how many units of each item that you need to produce in order to make that profit maximize. Solver will fill in the number of air conditioners and fans based on the model that you've built. So let's look at problem 2, which is going to be the same thing, just a different details. And you're going to fill in your objective function. The problem tells you how much profit you make per alpha 4 that you create. It tells you how much profit you make per beta 5 that you create. You're going to write a formula that says take the number of units times the profit to give you the profit overall. And this is the number we're going to want to maximize. The problem tells you you have one constraint in this problem. In this problem, that constraint happens to be labor. It tells you how much labor you need per alpha 4, how much labor you need per alpha 5. You're going to write a formula to get the total labor, which takes the alpha 4 and beta 5 units, times the amount of labor required for each, which you're going to fill in. You're going to put that formula, and then you're going to say that has to be less than or equal to 800. That's what it tells you. There's only 800 hours worth of labor available. So you're going to fill in this information. You're going to fill in your constraints just like you did with the previous problem. You're going to put in a formula for the profit. You're going to put in a formula to get your total labor. Then you're going to go to solver. You're going to go to solver. And you're going to say you want to maximize profit by changing the number of units. You're going to add your constraint. You just click on the cells. Whatever cell needs to be less than or equal to whatever other cell. Then you click solve. Solver will fill in how many of each unit needs to produce to maximize profit. It's very similar to problem 1. There's actually just less constraints. Now let's look at problem 3. Problem 3 is really the same problem as well. It's just more pieces to it. So let's look at that. Get rid of some of this stuff. Okay, so here's your problem 3 worksheet. And so our objective function here, we're going to put the profit in here per item. So we've got this table A that gives us a bunch of information about these different models of tools that we can create. And here's the models again. So let's start with this XJ201 model. The profit for this is the number of units times the profit per unit that we get over here from table A. The profit per unit for XJ201 is $9. So here you're going to actually write a formula that says take this number of units times this $9 that's in this cell, profit per unit. Then you'll do the same thing here. You'll take the number of units and multiply it times the profit per unit of that model from table A. So you'll fill that in all the way across. So then to get your overall profit, all you'll need to do is sum these cells. So in this cell, you're going to write a formula that says sum all of these. These are going to be formulas that take the number of units of that particular model times the profit for that particular model. Okay? So then we've got a bunch of constraints. The problem tells you there's a wiring constraint, drilling constraint, assembly, inspection, and minimums. So the wiring, drilling, assembly, and inspection constraints, we're going to do those the same way we've done them with the previous 2 problems. You're going to take the number of units you need to produce, you're going to produce, and times the amount of wiring time that's needed for that particular item. And that's again in table A. So you'll say the wiring time is this number of units times this much wiring. And then for this next item, you'll do the same thing. This number of units times the amount of wiring time from table A. So you'll do that all the way across. You'll do the same thing all the way across with drilling. Drilling information is in this table. So each item times the amount of drilling time it takes. The same thing with assembly. The assembly time is here in table A. And inspection times are here in table A. So you're going to fill in all of this information using the number of units times the amount of time it takes. So then you're going to sum all the way across, and you'll get the total wiring time, total drilling time, total assembly time, total inspection time. So you've already done the multiplication in here, so all you have to do here is sum it. And then these sums need to be less than the amounts given here. It tells us in table B that we can only have 15,000 hours of wiring, 17,000 hours of drilling, 2,600 of assembly, 12,000 hours of inspection time. So you're going to say that these totals for each of those tasks, you'll have constraints in solver that says that each of these sums need to be less than the time available for that activity. Then you've got minimums also. There's another constraint that says minimum. And table C tells us the minimum of each of these models that we have to make. We have to make at least 150 of XJ201. We have to make at least 100 of XM897. So those are additional constraints. So in this problem, we're going to end up with 8 different constraints. We're going to have a constraint that says the total wiring has to be less than or equal to 15,000 hours. Total drilling has to be less than 17,000 hours. Total assembly has to be less than 26,000 hours. Total inspection time has to be less than 12,000 hours. Then we're going to have more constraints that says the minimum number of XJ201s produced must be greater than or equal to 150. The number of XM897s produced has to be at least 100. The minimum number of TR29s to produce has to be equal to or greater than 300. BR788, the number of units produced has to be greater than or equal to 400. So when you go to solver, okay, before we go there, you've got this filled in using the profit numbers times the number of units from table A. This is going to be a sum. You'll have this filled in using the wiring numbers from table A times the number of units. This is going to be a sum. Same thing here. You'll use the table A times the number of units and then sum it. Table A times the number of units and then sum. Table A times the number of units and then sum. The minimums you're going to take from this table C. So we go to solver, you're going to maximize profit, this final overall profit number. You're trying to maximize that. And you're going to still do that by changing the number of each product used. And then you're going to add in these 8 different constraints. The sum of wiring needs to be less than the amount given. The sum of drilling needs to be less than. The sum of assembly needs to be less than a certain amount. And the sum of inspection needs to be less than a certain amount. Continue with your constraints. You're going to add a constraint that says the number of units of XJ201 greater than or equal to 150. Number of units of this greater than or equal to 100. So you're going to have a list of 8 different constraints here in this problem when you're done with it. And then once you have all that done, you'll click solve, and solver will tell you based on all those different constraints how many of each unit should be produced in order to maximize profit. So all 3 of these problems really are the same process. This one just has more detail, so it'll take a little bit longer. So if you have any questions, my contact information is in the instructor area. You can email me at any time and include your spreadsheet, and I can give you feedback. I look forward to talking with you in the discussion area. I also want to point out quickly before I run out of time, there's an additional video example in the additional resources area. So take a look at that one as well. So I look forward to talking with you throughout the week, and enjoy your week.